Okay, so in this video, we're going to solve systems using substitution with a variable not already isolated on one side. Now, if you're not already familiar with solving systems with the variable already isolated on one side, I suggest you see my video, Solving Systems Using Substitution Variable on one side already. All right. But for this one, these are a little more difficult than those problems because we have to solve for a variable first and then substitute our expression back into our other equation. So let's get started. All right, so the first thing you want to do is look for a variable that does not have a coefficient other than 1. All right, so we have three variables here, two x's and a y with a coefficient of 1. So I want to solve for one of those variables so I can isolate it and get it by itself on one side. I'm just going to choose the x here. All right. If I want to just solve for x, I'm going to take x plus y equals 3. Solving for x, I'm going to subtract y on both sides. Because that's a positive y, I am subtracting y from both sides. So this is actually a literal equation at this point. If you're not familiar with solving literal equations, see my video, Solving Literal Equations. All right. So x equals 3y. I've gotten that x by itself. I'm going to take this 3y, all right, and plug 3 minus y, I'm sorry, and plug it in for x in my other equation that I did not solve for. So I've solved this problem for x. X equals 3 minus y. I'm going to take this 3 minus y and substitute it for x in my other equation. All right. So instead of putting x, I'm replacing that with 3 minus y. And I bring down everything else. All right. So again, first up, look for a variable with a coefficient of 1. Solve for that variable. Take the result, plug it back in to your other problem or substitute it back into your other problem. So now I have only y's in my equation. If you substitute back in and you still have x and a y, you know you've done something wrong. So go back and check. But in this case, I have all y's. So I'm going to go ahead and just solve it using combining like terms and inverse operations. All right, so negative y plus 4y, that will give me a positive 3y equals 6. Left with the two-step equation, subtracting 3. 3y equals 3, and I divide both sides by 3. Y equals 1. All right, and so just like with any other system of equation, we need to find our other value because our answer is always an ordered pair. My y value is 1. So to find x, I can plug it into any of these equations. But I like to plug it into the one I solved for because I already got the x by itself. So x equals, instead of putting 3 minus y, y is 1. So 3 minus 1, x equals 2. So my answer is 2, 1. And again, you can plug it into any problem. So just to show you, if I plug in 1 for y here, x plus 1 equals 3. Solving for x, I still get x equals 2. All right, so either way, you're going to get the same answer. So my answer to this system of equations is 2, 1. So guess what? I'm solving this problem for the third time. And you want to know why? The first time, I copied down the problem wrong. I left out the negative. So something you could learn is when you're working out your math problems, always make sure you copy down the problem right the first time. So that way you don't get all the way down to the end of the problem and realize you made a mistake. And then you go back and you copied the problem incorrectly. So take that lesson from me. All right. The second time, when I recorded this video, I cut off the top of the problem. All right. So I'm solving this problem for the third time. So hopefully we can get through this without any issues. All right. So I want to locate the variable that is by itself with the coefficient of 1, rather. And that is my y value right here, or my y. So I'm going to, again, rewrite 4x equals y minus 1. I want to solve this equation for y, so I'm going to add 1. And I'm left with 4x plus 1 equals y. Can't combine those, they're not like terms. And remember, the reason that you want to find the variable that is by itself or has a coefficient of 1, because again, when you solve for it, it is just one step. All right. So I have 4x plus 1 equals y. I'm going to plug it back into the other equation that I did not solve for. Separating my work here, bringing down to 6x minus 2 instead of 2 times y. That is 2 times 4x plus 1 equals y. Again, got to put parentheses around it because I need to multiply a negative 2 by both terms. Distributive property, 6x minus 8x. Negative 2 times 4x is negative 8x. Negative 2 times 1 is negative 2 equals, and I made another mistake here. I put y. So you're probably wondering, why is there a y there? I'm going to just keep going because I caught my mistake and bring down that negative 3. All right. Double checking my work. All right. Copy down everything correctly. So let's keep it moving. 6x minus 8x. Negative 2x minus 2 equals negative 3. Adding 2. Cancels out. Negative 2x equals negative 3 plus 1. That is negative 1. Dividing by negative 2. X equals negative 1 divided by negative 2. So those negatives cancel out to make a positive 1/2. And it is okay to get a fraction. Don't think you're wrong just because you get a fraction. Double check your signs, of course. All right. So my x is 1/2. And to find my y value, I'm going to plug it in over here to what I solved for. So 4 times 1/2 plus 1 equals y. 4 times 1/2 is just 2, because half of 4 is 2. So 2 plus 1 equals y. 2 plus 1 is 3. So y is 3. So my answer is 1/2, 3. I'm just going to check it in that top problem. So if I plug in 4, not plug in 4, plug in 1/2 for x. And I plug in 3 for y. In that top equation, 4 times 1/2 is 2. 3 minus 1 is 2, so that checks out. All right, so my answer to this system is 1/2, 3. All right, so we're looking at our last problem here with solving systems using substitution. And always, again, our first step, we want to look for the variable that has a coefficient of 1. And again, we have this y right here that we want to solve for because it has a coefficient of 1. And the reason, again, that we want to choose a variable that has a coefficient of 1 is because to solve for it, it's just one step. I'm going to add x to both sides, and I get 4 plus x. If I would have chosen the negative x, I would have had to subtract y and then divide through by negative 1. It can be done, it's just one extra step. I like to keep it down to one step. All right, if you would have chosen one of these, you would have ended up with fractions, okay? So when you're solving systems of equations and you want to use substitution, always look for the variable that has a coefficient of 1. If you don't see that, then just try using another method like elimination or graphing. All right. So I'm going to finish solving this problem. Y equals 4 plus x. Making room for my work. I'm going to replace that 4 plus x and for y in my second equation that I did not solve for. So that's going to be 3x minus 2 times 4 plus x. So I want to multiply that negative 2 times both terms. So I put the parentheses equals negative 7. All right, so now I have all x's in my problem. Distributive property, negative 2 times 4x. 4 is negative 8. Negative 2 times x is negative 2x equals negative 7. Combining my like terms. 3x minus 2x is just x. And I'm left with the one-step equation. So I just have to add 8. X is equal to 1. Alright. And I've solved for x. So to find my y value, I'm going to plug it back in to my equation I solved for. Again, it's just the easiest one to use. So y equals 4 plus, instead of x, x is 1. So 4 plus 1 is 5. So my solution to this system is 1, 5. Check it. If I plug in 1 here and 5 here, that would be negative 1 plus 5. That does give me 4, so that checks out. And we've solved this system of equations.